Hi, hello everyone. This is Nepalidi sir from ANR Academy. In the last session, we discussed about basic functional equations, and today we are going to discuss how to solve the problems based on functional equations. They are interlinked with the topics continuity and differentiability, and also we are going to discuss previous year's questions. Last year in JEE 2023, there is a question based on functional equations. See this. If suppose f of x plus y, if it is equal to f of x plus f of minus 1, condition for all x comma y real, also given f dash of 0 that is equal to 2, then the question is find the value of f of minus 2. This is the question asked in JEE 2023. See the solution. First, ordinary method I am going to explain, and then we go for short method. You know, first principle, f dash of x equal to limit h tends to 0 f of x plus h minus f of x whole divided by h. This is first principle of derivative. I am going to use this functional equation. Now f dash of x written as limit h tends to 0. First term f of x plus h, it is like f of x plus y. Using this functional equation, f of x plus h written as f of x plus f of h minus 1 remaining minus f of x whole divided by h. Just in place of y, you have h here, so that f of x plus h written as f of x plus f of h minus 1 and remaining minus f of x. Here f of x gets cancelled. Therefore, f dash of x become limit h tends to 0 f of h minus 1 whole divided by h. As h tends to 0, denominator part becomes 0. So f dash x value not defined. I am going to use L'Hopital's rule. What L'Hopital rule says? You have to differentiate both numerator and denominator part. Now it is f dash of h derivative 1. Differentiation of numerator separately, differentiation of denominator separately. Now f dash of x value, that become f dash 0. Already in the question you have f dash 0 value, that is clearly 2. So that f dash x equal to 2, and that can be written as dy by dx equal to 2. F dash x is nothing but dy by dx. On cross multiplication, dy written as 2 dx and apply integration on both the sides. Then we get y equal to 2x plus c. And here you have to eliminate constant c. To eliminate the constant, I am going to write x value 0 and y value 0. Let us observe what happens. Let x comma y suppose 0 comma 0. Left hand side, if you substitute x y 0, f of 0, and in the right hand side what we get? F of 0 plus f of 0 minus 1. f of 0 gets cancelled, f of 0 become 1. So clearly the function passing through 0 comma 1. When you give input 0, output become 1. Replace x with 0 and y with 1. Therefore you will get the value of c. Therefore y is nothing but f of x. Function become 2x plus 1. But here the requirement function of minus 2. Replace x with minus 2. F of minus 2, that is 2 times of minus 2, minus 4 plus 1. That gives the result minus 3. So this is the general process with the help of first principle. Without using first principle, there is a short technique. Let us observe. Given functional equation, first I am going to write f of x plus y is given as f of x plus f of y minus 1, given it is true for all x comma y real. Also there is a condition, that is f dash 0 equal to 2. Also given f dash 0 equal to 2, and the aim is to find f of minus 2. This one is the question. Let us see the short technique. There are two variables x and y. I am going to differentiate partially with respect to y, applying partial differentiation with respect to y. What happens? Observe. It become f dash of x plus y. Internal part x plus y derivative just 1. In the right hand side, when you differentiate partially with respect to y, you have to treat x as constant in this case. So constant derivative here, it is 0. Next, f of y, its derivative f dash y, constant derivative 0. So that we get x plus y, it is equal to f dash y. Given that f dash 0 value 2, put y equal to 0 in this. If you substitute y equal to 0, f dash of x become f dash of 0. F dash of 0 is nothing but 2. But derivative dy by dx, that is equal to 2. dy simply 2 dx. On integrating both the sides, we get y equal to 2x plus c. Yes, you got the function, but you have to eliminate constant also. Clearly, by substituting x comma y, origin 0 comma 0, what happens? Left hand side f of 0, right hand side f of 0, 2 times of f of 0 minus 1. Therefore, f of 0 become 1. When you put x value 0, y value become 1. x 0, y 1 means c value 1. Therefore, y become 2x plus 1. We need to find f of minus 2. So, minus 4 plus 1 gives the result minus 3. The same result you got, just partially differentiating with respect to y by treating x as constant. So, this is a simple proof. Let us move to the next question. Another question I am going to write. Suppose that if you have the question, f of x by y, it is equal to f of x minus f of y for all x comma y they are more than 0 and f dash 1 equal to 1, then find f of x. This is the question. By using first principle also you can solve this, but I am not going to use partial, I am not going to use first principle. By partial differentiation I am going to solve this. Clearly f of x by y, that is given as f of x minus f of y. Partial differentiation apply with respect to y. Then what we get? It is f dash of x by y derivative with respect to y minus x by y square it is. Next, since x constant, its derivative 0 and it is minus f dash of y. Neglecting negative sign, what we get? X into f dash of x by y equal to y square into f dash of y. See here, f dash 1 you have 1, that is if I write y value 1, f dash y you have here, so internal part y suppose 1, then you can use this. Let the value of y equal to 1, that is x into f dash of x equal f dash of it is 1. Right. I am going to write the value of y 1. So f dash 1 multiplied by 1 square. You know that f dash 1 value 1. It become 1. F dash x equal to 1, nothing but dy by dx equal to 1. Implies dy written as just dx. Okay. On cross multiplication it is. Applying integration on both the sides, we get y equal to x plus constant. And observe, x comma y they are positive. Put x, y both 1, 1. Then what happens? F of 1 equal to f of 1 minus f of 1. F of 1 become 0. When you give input 1, output 0. Input 1, output 0. So that what is the value of c? C minus 1. And hence the function f of x become x minus 1. This is the way of approaching problems based on functional equations. Let us discuss another question. Suppose if you have the question, if f is differentiable function such that f of x plus y whole divided by 3, f of x plus y by 3 equal to 2 times of f of x, it is 2 plus f of x, 2 plus f of x plus f of y whole divided by 3, where x comma y real values, and also given f dash 0 equal to 2. find f of x. This is the question. See the solution for this. Again, by using partial differentiation without using first principle, you have f of x plus y divided by 3 as 2 plus f of x plus f of y whole divided by 3 it is. Now, if you apply partial differentiation with respect to y, partial differentiation if you apply with respect to y, then it become f dash of x plus y divided by 3. Internal part x plus y by 3. Differentiation with respect to y, that gives 1 by 3. Next, 1 by 3, that is constant in the right hand side. If you differentiate partially with respect to y, treating x constant, these two gets 0, only you will get f dash of y. 3 gets cancelled, and hence we get f dash of x plus y divided by 3, that is equal to f dash of y. Observe here, you have f dash 0 value 2. So put y equal to 0. If you put y equal to 0, then what happens? Left hand side that become f dash of x divided by 3. In the right hand side it is f dash of 0. What is f dash of 0? You have 2. So f dash x by 3 equal to 2. Clearly x is real number, x by 3 also real number. Whatever the real value you have here, output is 2. So that I can write f dash of x also 2. X real number implies x by 3 also real number. Whatever the real input you have, it become 2. Already x real you have. So whatever the real, it is 2 f dash x value. So nothing but dy by dx value become 2 and dy equal to 2 dx. On integration, y equal to 2x plus c. To get constant, let us suppose both x comma y zeros. If you put both x, y zeros, what happens? Observe. Left hand side f of 0, right hand side 2 plus 2 times of f of 0 divided by 3. 3 times f of 0 minus 2 times f of 0, that is f of 0 become 2. For input 0, output is 2 here. Input 0, output 2. So that 2 equal to 2 times 0 plus c, and hence the value of c is 2. Therefore, y equal to 2x plus 2. This is required function. Let us move to the another question. Suppose the question, f of x plus y, that is given as f of x plus f of y plus x square y plus xy square, and f is differentiable function. Limit x tends to 0, f of x divided by x is given as 1. Find f of x. This is the question. See here, f is differentiable as well as there is a functional equation, and one more condition is there, limit x tends to 0, f of x by x equal to 1, then we need to find the value of f of x. First I am going to solve this directly by substituting x value 0, it is not 1. So applying L'Hopital's rule. We get limit x tends to 0, f dash of x divided by 1 equal to 1 implies f dash 0 equal to 1. Remember, this is one result given in the question. Directly, without giving f dash of 0 equal to 1, indirectly given limit x tends to 0, f of x divided by x equal to 1. Yes, now proceed. Partial differentiation with respect to y. F dash of x plus y, internal part derivative 1. Next, f of x derivative 0, f dash of y. Next, since partial differentiation with respect to y, y derivative 1, only x square you will get. Next, x constant, y square derivative 2y. This is partial differentiation with respect to y result. Now, to use the condition f dash 0 equal to 1, let y equal to 0. Put y equal to 0. Then what happens? Observe. It is f dash of x. F dash 0, nothing but 1. Next, plus x square as it is, y 0. F dash x, we got 1 plus x square. F dash x is nothing but dy by dx, that is 1 plus x square. In the next step, I can write dy equal to 1 plus x square of dx. Apply integration on both the sides, we get y equal to x plus x cube by 3 plus c. 1 integration x square integration x cube by 3. Now, to get constant in this, let us substitute the values. Put x equal to 0 and y equal to 0 in the original functional equation. Left hand side you will get f of 0. In the right hand side, f of 0 plus f of 0, that is 2 times of f of 0. And hence f of 0 become 0. It is possible only when f of 0 is 0. So, the function which is passing through origin, input x 0 implies output y also 0. Therefore, writing x0 y0 in this, c become 0. Therefore, function y equal to f of x, it is x plus x cube divided by 3 plus c. So, these are the model questions which are based on functional equations, and some of the questions in which you have in previous examinations. I hope you understand everything without using the first principle, just with the help of partial differentiation and differentiation also, it is interlinked with the integration also. Just with the help of integration, differentiation and partial derivatives, we can easily find the functional value when functional equation is given. Thank you so much.